The electrolysis of zinc chloride can give different electrode products depending on the conditions used. Suggest the products formed at each electrode in the following cases. One space has been filled for you. So ZnCl2 liquid is molten ZnCl2. So we'll have no ions apart from Zn2 plus and Cl negative. No ions apart from them. So obviously chlorine at the anode and zinc at the cathode. Then ZnCl2 concentrated aqueous solution. Concentrated aqueous solution, again chlorine at the anode, because even though OH negative discharges in preference to chloride ions, when Cl negative is concentrated, a different thing happens. Chlorine is produced instead of oxygen. And we'll have so now for zinc and hydrogen, the competition is between zinc and hydrogen. So let's see. Zn2 plus 2E negative gives Zn, and this I think is minus 0.76 volts. Let me quickly check. Yeah, minus 0.76 volts, and this will be 2H plus 2E negative gives H2, and this is 0 volts. So you can see that H plus ions have a greater drive to accept electrons to form H2 than Zn2 plus ions to form Zn, because this is negative, which means from Zn2 plus to Zn it is quite unfeasible. It is quite not feasible. So hydrogen will be produced instead of zinc because H plus ions discharge more readily at the cathode. They accept electrons more readily. So hydrogen gas will be formed at the cathode. And ZnCl2 dilute aqueous. Now in case of dilute, obviously OH negative discharges in preference. So oxygen and hydrogen, this remains the same. Whether concentrated or dilute, this remains the same. Now let's move forward. Use relevant information from the data booklet to identify the substances formed at the anode and at the cathode when aqueous solutions of the following compounds are electrolyzed. So aqueous solutions, which means not molten, which means H plus and OH negative will be present. Now F, fluorine. So according to the discharge series, OH negative discharges in preference to fluoride ions, so oxygen will be formed. Sorry about that. Oxygen will be formed because OH negative discharges in preference to F negative. So let's do all the anode products first. SO4, so oxygen again, because OH negative discharges with more ease compared to SO42 negative. And MgBr2, this will be bromine gas, because bromine, or we can also say Br2, because Br negative discharges in preference to OH negative, so definitely this has to be bromine. Now product at cathode, so it will be Ag plus E negative gives Ag, which is plus 0.80 volts. This has an electrode potential of plus 0.80 volts. And the other competitor is H plus, 2H plus 2E negative gives H2. So in this case, it's 0. We know it's 0 volts. So this means that since this is more positive, for Ag it's more positive. Sorry, I forgot to make the plus. So since it is more positive for Ag plus, it has a stronger drive to form Ag. So the product at cathode will be Ag. Now in the case of FeSO4, which is Fe2 plus, now the electrode potential for this one is minus 0.44. Now since this is more negative than that for H plus, so now let's forget silver. We are no longer dealing with silver. We are dealing with iron and hydrogen. So since this is more negative than that for H plus, H plus will discharge more readily, so hydrogen will be formed, H2 gas will be formed. And for MgBr2,